What I want to do now is investigate what happens with the voltage through a series and a parallel circuit. So I've got a voltmeter here, and a voltmeter is measuring the energy change, the potential energy, electrical energy change from one side of the lamp to the other side of the lamp. It's obvious that this component here, the power supply, is giving energy, and this lamp is using energy. So we're giving potential energy here, and that potential energy is used by going through this lamp. So if I connect the voltmeter across the power supply, you can see that in this case about 6.4 volts of energy is being supplied by the power supply. It's giving the electrons 6.4 volts worth of energy. And if I connect it across the lamp, what you can see is that that energy is almost all used up by the lamp. There's a little bit missing, so it was 6.41, it's now 6.38. So we've lost a little bit of energy in these wires here, but most of the potential energy, so most of the voltage, is used up by this lamp. So the power supply gives 6.4 volts of energy, and the lamp is using 6.4 volts. Now what I'm going to do is I'm going to add in another component. So I'm going to add in another lamp into here and see what effect that has. Well, straight away what you can see is that the lamps are dimmer. So let's see what's going on with the energy. Well, the power supply is still giving the same energy as before. It's still giving 6.4 volts worth of energy. But now it's got to supply that to two lamps. So this lamp here is getting 3.1 volts. So some of the energy from the power supply is being used up in this lamp, and some of it is being used up in this lamp. But if I added up the energy, this 3.2 and the energy from this lamp, it adds up to what the power supply is giving. So the power supply is giving me 6.4 volts of energy, and each of the lamps is using 3.2 volts of that energy. I can check that again, just if I add one more lamp in here. So let's add a third lamp just to check what we found. And what we should find now is that the 6.4 volts given by the power supply is now shared by all three lamps. So they're all going to get just over 2 volts. So if we connect to this lamp here, okay, so there we go, nearly 2 volts. If I connect to this lamp here, just over 2 volts, so 2.2, and again 2.3 to 2.4 volts. So if I added the energy from this one, and this one together, I would end up with the 6.4 volts I started with. So I've got 2.3 used by this lamp, 2.2 used by this one, and 1.8 used by this one. So overall, the energy given by the power supply is shared by the light lamps, and that's why they all appear dimmer, because they're not getting all of the voltage that's giving out by the power supply. They're only getting a proportion of it. In these series of experiments, we were investigating the voltage in a series and a parallel circuit. So let's start with a series circuit. So here's our series circuit. It's just got one lamp in it. And I've added a voltmeter across the lamp and a voltmeter across the power supply. Voltmeters are connected across devices because they measure the energy change from one side of the device to the other. So they're measuring what we call the potential difference between that side of the lamp and this side of the lamp. And in this first experiment, we recorded a voltage on this voltmeter as 6.4 volts. So the electrons are given 6.4 volts worth of energy by the power supply. And they only meet one component on the way around, and that's this lamp here. So they deposit 6.4 volts of energy in this lamp here. So in this first experiment, the voltage supplied by the power supply is equal to the voltage supplied to the lamp. We've now added another lamp into the circuit. So here's our second series lamp. So we've got 1, 2, and we put another voltmeter in here. And what we find is that we still get 6.4 volts from the power supply, but the voltage for this lamp is 3.2 volts, and the voltage for this lamp is 3.2 volts. And we could see that both lamps were actually dimmer. So the voltage that's been given to us, the energy that's been given by the power supply, 6.4 volts of potential, of that 6.4 volts of electrical potential, this lamp got 3.2 and this lamp got 3.2. So you can imagine the electrons almost like lorries, and they're traveling around this road, and they deposit some of their energy in this lamp and some of their energy in this lamp. And the energy supplied to this lamp plus this lamp adds up to what's given by the supply. Finally, we've added a third lamp into our series circuit. So we've got 1, 2, 3. And we recorded the voltage. Again, the power supply was giving 6.4 volts. But in this case, this lamp got 2.3 volts. This lamp here got 2.2 volts. It's got a slightly different resistance, so slightly different voltages. But if we added up the 2.3 and the 2.2 and the 1.9, it still adds up to the energy that's given by the power supply. So the electrons leave the power supply with an amount of energy, and they deposit some of that energy in that lamp, some of that energy in that lamp, and some of that energy in that lamp. And although the current's the same all the way around the circuit, the amount of energy each lamp gets depends on its resistance, and also the lamps are now much, much dimmer.